Hello everyone, this is your course instructor Monisha Raj.K.H, Assistant Professor, Department of ECE, Sai Vidya Institute of Technology. In this lecture video, we'll be starting with Module 1 of Information Theory and Coding. Before going into Module 1, we'll see what are the contents we'll be studying in Module 1. In Module 1, we'll be seeing about the Introduction to Information Theory, Measure of Information, information content of message, average information content of symbols in long independent sequences as well as long dependent sequences, Markov statistical model for information sources, entropy, and information rate of Markov sources. The textbook to be referred for Module 1 is Digital and Analog Communication Systems by K. Sam Shenmugam. Before going into actual content of Module 1, we need to know what is basically an information theory and coding. Before knowing what is information theory and coding, we need to know what is an information. The meaning of the word information in information theory is basically a message. Information is the source of communication system, which might be voltage or current or power, speech, picture, anything. After knowing what is information, what do you mean by information theory? Information theory is the mathematical approach where the quantization of a message take place, measuring of a message take place, storage of a message takes place, and communication of a message takes place. Combination of all these things makes information theory. What do you mean by coding? Coding is compression of data, fighting against the noise, and encryption of data. These all things come under coding. So next is, what is the purpose of information theory? Information theory is basically a notion of data source and data transmission channel. The purpose of information theory is for increasing the efficiency and reducing the error rate of data communication over noisy channel. Why we need to study information theory? We need to study information theory for feasible transfer of data, for practical implementation, that is, with less time and more speed. This is basically an idea about what is information theory and coding, what is the purpose of information theory, and why we need to study information theory. After knowing the gist about what is information theory and coding, next we'll move on to further what we'll be learning in Module 1. So, in the design and analysis of a communication system, two important things need to be considered. The first one is the case where if information source is given, and the second one where if a noisy communication channel is given. What if an information source is given? When an information source is given, we need to think how to evaluate the rate at which the source is emitting information. What if a noisy communication channel is given? We need to think how do we evaluate the maximum rate at which reliable information transmission can take place over the channel. Then information sources can be classified into analog and discrete. What do you mean by analog? Analog source emits a continuous electrical waveform, which might be voice or voltage. Discrete source emits a sequence of symbols. The output of the discrete information source is a string or sequence of symbols. Next, we'll be seeing the functional block of digital communication system. In digital communication system, the first block is discrete information source, where the output of the discrete information source is sequence of symbols, which is given to the source encoder, where in source encoder, these sequence of symbols are converted into binary input stream. The channel encoder just acts as a channel, and the output will also be a binary stream. The modulator modulates the signal, and output of this can either be analog or electrical signal. This This electrical communication channel carries these analog or digital signals, and noise will be added at this position. Next, it will be sent to demodulator, and again the output of the demodulator is binary stream, where analog or electrical signal is converted into binary stream. And channel decoder acts as a channel. It is sent to the source decoder, where source decoder converts binary input stream to the sequence of symbols. This is the functional block of digital communication system. Next, we'll be moving on to block diagram of information source, where we'll come across information source, encoder, channel, decoder, and user information. What is information source? Information source is a discrete source emitting discrete message symbols S1, S2 up to SQ with the probabilities of occurrence of P1, P2 up to PQ respectively. The sum of all these probabilities must be equal to unity. What do you mean by source encoder or encoder? Encoder converts the symbol sequence into a binary sequence of zeros and ones by assigning code words to the symbols in the input sequence. Source symbols occurs at the rate of RS symbols per second. What is the function of a communication channel? A communication channel provides electrical connection between the source and destination. The signals would be corrupted by unwanted, unpredictable electrical signal referred as noise. The main objective of communication system design is to reduce the ill effects of noise as much as possible. The source decoder converts the binary output of the channel decoder into the symbol sequence. This is a function of source decoder. The transmitter couples the input message signal to the channel. That is, transmitter comprises of information source and encoder. The receiver is decoder and user information. Receiver will always identify the symbol sequence and match it with the correct sequence. After understanding the block diagram of information system, we'll next move on to measure of an information. Before knowing the measure of an information, we need to know what is an information content of a message. For this, we'll be considering the scenario. Suppose you are planning a trip to Miami, Florida from Minneapolis in the winter time. To determine the weather in Miami, you telephone the Miami Weather Bureau and receive one of the following forecasts: mild and sunny day, cold day, possible snow flurries. Here you need to explain the amount of information contained in each statement. So the amount of information received is obviously different for these messages. In the first case, that is, the first message contains very little information, since weather in Miami is mild and sunny most of the time. In the second scenario, the forecast of cold day contains more information than the first information, since it is not an event that occurs often. The third case, in comparison to the first one, the forecast of snow flurries conveys even more information, since the occurrence of snow in Miami is a rare event. Thus, on an intuitive basis, the amount of information received from the knowledge of occurrence of an event is related to the probability or likelihood of occurrence of an event. From the above examples, we get to know that the snow flurries is a very rare event. That is, from the information what we have received from this is related to the probability of occurrence of that event. So, from the above information, we get to know the information of a particular scenario is very important for us to know the occurrence of that event. Therefore, the message associated with an event least likely to occur contains most information. This is a scenario for understanding information content of a message. Next is, what is measure of information? A measure is necessary to know the information content of various messages produced by an information source. Let us consider an information source producing independent sequence of symbols from source alphabets S equal to S1, S2, S3 up to SQ. This symbols might be any alphabet, it might be M also, with the probabilities P equal to P1, P2 up to PQ respectively. Let Sk be the symbol chosen for transmission at any instant of time with a probability Pk. Then the amount of information or self-information of Sk is given by Ik, that is the information, self-information is inversely proportional to probability, or Ik equal to log of 1 by Pk to the base 2 bits. When we are considering logarithm, if it's base 2, we represent it in the form of bits. If it's base 10, we represent it in the form of Hartley. And if it's base E, we represent it in the form of Nats. Next is, why logarithmic expression? It is because it cannot be negative. The information content or self-information of any message cannot be negative. Each message must contain certain amount of information. The second one is the lowest possible self-information is 0. If a self-information is 0, that means the event is sure to occur. That is, probability of the event will be 1. Third one is more information is carried by less likely message. Fourth one is when independent symbols are transmitted, the total self-information must be equal to sum of the individual self-informations. These are the advantages of using logarithmic expressions for measuring information. Next, we'll be seeing a numerical. A source puts one of the 5 possible messages during each message intervals. The probabilities of these messages are P1 equal to half, P2 equal to 1 by 4, P3 equal to 1 by 8, P4 equal to 1 by 16, P5 equal to 1 by 16. Find the information content of the messages of these messages. So let us say the messages of the symbols might be M1, M2, M3, M4, and M5. As I told in the explanation, it might be M, S, or any alphabet. So first, information content of M1 is probability of M1 would be 1 by 2. So substituting 1 by 2 in place of P1, log of 1 by 2 to the base 2, taking 2 to the numerator, we'll get it as log 2 to the base 2, it will be 1 bits. Second one, M2. I of M2 equal to log of 1 by P2 to the base 2. P2 is 1 by 4. So taking again 4 to the numerator, log 4 to the base 2 equal to 2 bits. I of M3, we again take P3 value, that is 1 by 8. So substituting P3 as 1 by 8, take 8 to the numerator, again log 8 to the base 2, we get it as 3 bits. M of 4 and M of 5 is 1 by 16. So substituting P4 and P5 as 16, taking 16 to the numerator and log 16 to the base 2, we get it as 4 bits. This is about measure of information. In the next lecture video, we'll be continuing with module 1. Thank you.